At 2:40 p.m. local time, a Ukrainian Air Force Su-27 flanker fighter jet screamed over the hills of Kharkiv province, flying low at just 500 feet. The pilot navigated turbulent air currents while glancing at an iPad mounted on the cockpit dashboard. The screen displayed GPS coordinates for 2 concrete buildings in Petrivka village, housing approximately 120 Russian soldiers from a motorized rifle company. Those troops had no idea what was about to hit them. The target coordinates were pinpointed with an initial error margin of just 33 feet from the navigation system, though weather conditions and electronic jamming could widen this gap. Flying at such a low altitude posed a cascade of risks, potentially ending the mission in the next 42 seconds. Crosswinds of 25 miles per hour, combined with the hilly terrain, created swirling air currents that shook the aircraft relentlessly, heightening the risk of losing control or damaging equipment. Before diving into today's main story, if you support Ukraine, drop a 1 in the comments. Under each wing, a Bru-61 bomb rack carried 4 American-made GBU-39 small-diameter bombs. These weapons weren't designed for Soviet aircraft. The GBU-39, measuring 5.9 feet long, 7.5 inches in diameter, and weighing 250 pounds, uses a GPS/INS guidance system with a glide range of up to 68 miles when released from 40,000 feet. Ukrainian technicians had improvised mounting adapters, but the intense airflow at low altitude was loosening those connections. Each time the jet hit turbulent air, vibrations rattled through the makeshift mounts. The 4 bombs created drag, sapping energy and burning fuel faster than planned. The jet's AL-31F engines consumed 15% more fuel than expected. Each AL-31F engine delivered a maximum thrust of 27,550 pounds. But at low altitude, denser air reduced efficiency, pushing fuel consumption from 1.54 pounds per second to 1.77 pounds per second. The pilot quickly calculated. Fuel was just enough to reach Petrivka, drop the bombs, and return. The iPad flickered between GPS and GLONASS signals, causing a 164-foot error in target coordinates. This deviation stemmed from Russian R-330Z GTEL electronic jamming systems operating at 1.5 to 2.5 GHz, disrupting the L1 satellite signal. Flying at 500 feet and 518 miles per hour, the pilot couldn't spare a hand to fix the error and planned to adjust after climbing. Beneath the fuselage, the L-203 Gardania jamming pod ran at full power, emitting signals to counter modern radars. Operating in the 1 to 2 GHz range, it could disrupt the Russian 96 L6E cheeseboard radar, but struggled against the 92 N6E gravestone fire control radar of the S-400 system. Despite its 1980s technology, every second of delayed detection brought the pilot closer to the drop point. Whether he'd make it remained uncertain. Some 75 miles to the northeast, a Russian 96 L6E cheeseboard radar scanned the skies. This radar could detect targets up to 186 miles away. Operating in the C-band with a peak power of 60 kilowatts, the 96L6E could spot targets with a radar cross-section, RCS, as small as 1.08 square feet. The pilot used the terrain, flying low to mask his radar signature behind hills. Occasionally, cresting a ridge exposed the jet briefly to radar sweeps. In the headset, the SPO-15 Barroso warning system chirped intermittently, but the Soviet-era technology couldn't distinguish between routine scans and a target lock, a potentially deadly limitation. The SPO-15 offered only 3 threat levels: low, medium, high, without identifying the radar type or threat severity, forcing the pilot to rely on instinct and experience. A greater threat emerged 37 miles out when the Russian S-400 system's 92N6E Gravestone fire control radar activated. Capable of locking targets at 155 miles, it guided 48 N6E missiles traveling at Mach 12 with a 124-mile range. Once detected, the pilot had seconds before a missile could close in. The only defense was staying below radar coverage, but that meant battling dense, turbulent air near the ground. Below 656 feet, wind shear up to 164 feet per second threatened to destabilize the jet. 7 miles from the pull-up point, the pilot ran a final check. The master arm switch was on. Weapon status showed 3 green lights and 1 flashing yellow on Bomb 4 due to a faulty Ukrainian-made mount. The issue stemmed from a non-compliant Milstead 1760 connection, disrupting signals between the jet and the bomb. Drop parameters were set, but needed confirmation. Turbulence made reading the cockpit displays a challenge. At Petrivka base, the duty officer monitored radar as usual. The 96L6 cheeseboard operator reported intermittent signals, possibly terrain clutter or civilian vehicles near the border. The base's Panzer S-1 air defense system was offline for maintenance. Equipped with a 1RS-21E radar and 2 A-30M 30mm cannons, the Panzer S-1 could down targets at 12.4 miles, but required 45 seconds to activate from standby. In the 2 barracks, Russian soldiers rested, 46 miles deep inside Russian territory, unaware of any threat. Petrivka's base featured 2 reinforced concrete buildings, each 3,229 square feet, built to withstand a 110-pound TNT blast, but not the GBU-39's concrete-piercing warhead. Suddenly, the jet's SPO-15 shifted from intermittent beeps to a steady warning. An SA-21 Growler radar from Belgorod had detected the pilot as he crested a hill. Part of the S-400 system, the SA-21 used X-band with a 0.4-degree angular resolution, capable of locking on to a small target like the Su-27 at 93 miles. No longer hidden, the pilot slammed the throttle to full and yanked the stick, pulling the jet into a 4.5G 60-degree climb. The horizon vanished, replaced by blue sky. The 4.5G force pressed 992 pounds of pressure onto the pilot's chest, making breathing difficult and risking blackout if sustained beyond 10 seconds. He abandoned the safety of low altitude, exposing himself to every radar in western Russia. To hit the target, he needed to reach 28,000 feet in 42 seconds. Warning lights flashed across the cockpit. The Su-27's flight controls struggled with the aggressive maneuver while carrying 4 250-pound bombs, shifting the center of gravity 0.98 feet forward, causing the nose to pitch up. The pilot adjusted the angle of attack constantly, battling nausea as G-forces pinned him to the seat. His left hand tweaked the throttle, his right gripped the stick as the jet shuddered violently. The SPO-15 screamed at maximum alert. "20 miles behind, a 48N6E missile launched, climbing to 35,000 feet before diving at Mach 12. Carrying a 397-pound explosive warhead, it could destroy targets within a 66-foot radius. The pilot had a slim chance. At his peak altitude, he'd enter a brief safe zone before the missile switched to its terminal phase. Timing was critical. At 25,000 feet, the left engine surged due to thinner air, creating a 5% thrust imbalance. The pilot throttled back the left engine to 95%, matching the right, but lost some altitude. Through the heads-up display, altitude climbed 26,000 feet, 26,500 feet. The missile was 15 seconds from impact. Frost coated the canopy at 27,000 feet, forcing the pilot to wipe a small patch clear with his glove. The artificial horizon showed the jet leveling off, nearing the drop point. The weapons panel reported 3 green lights and 1 yellow on Bomb 4 due to the connection issue. With no time to troubleshoot, he decided to release the bombs, hoping the 4th would activate after release. At 28,000 feet, the pilot held the jet steady for 3 seconds as the computer calculated drop parameters. The iPad stabilized, displaying the target with green triangles. The system was ready. Behind, the SA-21 missile reached 33,000 feet, entering its search phase. The APP-50 decoy system auto-deployed, releasing 12 canisters, each with 50 radar reflective strips, mimicking the jet's RCS. The pilot released the bombs in sequence, bombs 1 and 2 from the left rack, then 3 and 4 from the right. The yellow light on Bomb 4 turned green upon release. The 4 GBU-39s glided toward the barracks, their wings deploying, carrying them toward the unsuspecting Russian troops. After release, the pilot shoved the stick forward, diving with a -2.5 G force, creating a weightless sensation as blood rushed to his head, blurring vision for 3 seconds. The altimeter plummeted. As the SA-21 missile veered to pursue, the Su-27 dropped below 15,000 feet out of its engagement range. The missile self-destructed, scattering debris over an empty field within a 1,640-foot hazard radius, causing no damage. The pilot had done his part, but the mission wasn't over. As the pilot dove to safety, the 4 smart bombs began their attack run. Each carried a 36-pound warhead, traveling 46 miles through Russian airspace. Their wings allowed a 15-foot glide per foot of altitude lost. They faced electronic jamming from Ukraine to the target. 30 miles from Petrivka, a Russian R-330 ZASH Zhitel vehicle emitted 10 kilowatts of jamming on GPS L1 and L2 frequencies, inducing a 164-foot positioning error. The bomb's GPS receivers detected the interference and switched to the military L5 band, though accuracy dropped from 3 feet to 10 feet, still sufficient to hit a building but possibly off the precise target. Bomb 2 lost GPS after 90 seconds, switching to inertial guidance, with accuracy degrading to a 49-foot error. The GBU-39's laser gyroscopes, drifting at 0.01 degrees per hour, couldn't fully compensate for prolonged GPS jamming. The bomb's computer cross-referenced old data to adjust. Without satellite signals, it flew nearly blind. A Russian K-52 helicopter inadvertently crossed the bomb's path, its pilot unaware of the 379 mph projectiles. The K-52's arbalete radar, with a 15.5-mile range, missed the bomb's 0.11 square foot RCS. The bomb's radar detected the helicopter as a collision threat, adjusting 5 degrees to pass 656 feet clear. The helicopter pilot never knew he'd narrowly escaped. At 8,000 feet, the bombs hit 40-mile-per-hour crosswinds from the west, equivalent to a Beaufort scale 8, pushing them toward nearby civilian apartments. Without correction, the winds could deviate their path by 328 feet. The bomb's control systems worked overtime to stay on course, with Bomb 3's actuators vibrating at their limit. Bomb 3's wing actuators, operating at 50 Hz, shook beyond design limits, risking failure. 8 miles from the target, a Russian Tor M2U radar detected the bombs. Its 9S-36 radar could spot .54 square-foot RCS targets at 9.3 miles. The operator mistook them for birds, as the signal resembled migrating geese. But birds don't fly in formation at 399 miles per hour. He reported to superiors, but it was too late. The electronic warfare intensified. The JETEL system ramped up power to overwhelm the bomb's GPS, but their CRPA anti-jam antennas mitigated 90% of the interference. Bomb 2 regained GPS, though with a 98-foot error, and began correcting its path. 2 minutes from impact, the bombs descended to 5,000 feet, nearing the target. From the ground, they were too small to see, too silent to hear. In the eastern barracks, Russian soldiers played cards and chatted. In the western building, dinner was being prepared. The eastern barracks housed 60 troops, mostly from the 3rd Motorized Rifle Company, while the western held 50 soldiers and a small armory with 441 pounds of munitions. At Petrivka's command post, the duty officer received a report of 4 airborne objects, likely guided munitions, 5 miles out and closing. He triggered the alarm, a 120 decibel siren echoing within a 1.24-mile radius. But the troops had just 20 seconds to react. The bombs kept coming, unstoppable. The Pantsir S-1 crew scrambled to their station. The system needed 45 seconds to activate, but they had less than 30. The radar began scanning, and the 30mm cannons swiveled upward, but they couldn't track 4 small targets moving at 379 miles per hour. The 2A-38M cannons, firing 5,000 rounds per minute, missed the lead bomb by 98 feet, limited by a 45 per second slew rate. At 500 feet, Bomb 3 overcame the crosswinds, realigning with the target. All 4 bombs breached the defensive fire. At 2:51:03 p.m., the first bomb pierced the roof, its steel nose punching through 2 concrete floors before its 36-pound warhead detonated, unleashing a shockwave that shattered concrete and vaporized steel. The 435 psi blast within a 16-foot radius obliterated the reinforced structure. The eastern barracks facade exploded, windows and walls turning into deadly shrapnel, flying up to 656 feet. 17 seconds later, the second bomb struck the western building, collapsing it entirely. The second explosion triggered the armory's 331-pound munitions stockpile, causing a secondary blast equivalent to 331 pounds of TNT. The western barracks took the remaining 2 bombs almost simultaneously. The third hit the main entrance, the fourth pierced the roof. With 72 pounds of explosives detonating together, the building disintegrated, walls blown outward. The dual blasts created a 164-foot dust cloud, reducing visibility to under 33 feet. In 30 seconds, both barracks and all Russian troops inside ceased to exist. The strike was part of Ukraine's counteroffensive in Kharkiv, targeting Russian logistical strongholds. Ukrainian forces had used Bayraktar TB2 drones to scout Petrivka, pinpointing the barracks and enemy radar positions.
Intelligence was relayed to the Su-27 pilot via a secure data link, though Russian jamming disrupted communications for 5 minutes before the drop. Simultaneously, a Ukrainian artillery unit 12.4 miles from the border fired 10 155mm shells at a decoy target 9.3 miles from Petrivka, distracting the 96L6E cheeseboard radar for 3 critical minutes. This coordinated strike was part of a broader strategy to weaken Russian border defenses.
After the GBU-39s completed their mission, the Su-27 pilot, now at a safe altitude, turned to observe the results through a remote viewing system. The FLIR infrared camera, with 1280 by 720 resolution, showed Petrivka's barracks reduced to rubble, with thick smoke confirming a successful strike. Verifying the target's destruction, the pilot checked fuel and aircraft status. The engines ran stably, but only 661 pounds of fuel remained, enough for 7 minutes at an economical 373 mph. He adjusted course, slowed to conserve fuel, and stayed low to evade enemy radar. At 656 feet, the pilot used the hilly terrain to mask his radar signature, maintaining 404 miles per hour to avoid the SA-21 radar sweep. On the return, the SPO-15 warning system fell silent, the skies deceptively calm. But a nearby 92N6E gravestone radar began scanning again, forcing a detour through a deep valley. After over an hour of intense flight, the Su-27 landed safely at a Ukrainian airbase 31 miles from the border, protected by 2 NASAMS air defense systems. The pilot stepped out, exhausted but satisfied, knowing his high-risk mission had advanced Ukraine's defense. Comparing the cost-effectiveness of the strike highlights stark disparities. Ukraine deployed 1 Su-27, valued at $30 million, and 4 GBU-39 bombs at $70,000 each, totaling $280,000 in munitions. Fuel and maintenance for the 90-minute mission added roughly $50,000, bringing Ukraine's cost to $330,000. Russia lost 2 $2 million barracks, 120 soldiers with $50,000 training costs each, $6 million, and a $500,000 munitions stockpile, totaling $8.5 million, 25 times Ukraine's expenditure. Russia also faced indirect losses from disrupted logistics, estimated at $3 million. Ukraine's strike was highly efficient, but the pilot's risks and stress were immense. If you support Ukraine, comment 1.